much. Thank you for the kind invitation. So today I will be talking about what I call creative AI. But my goal is really to explain you how artificial intelligence could make us humans more creative. So you could think that I call creative AI the use of generative models, such as ChatGPT, DALL-E from images. But you know that these generative models, they just train on huge amount of data, and then they will provide us the most expected answer given all this data. This is really impressive. This can be really useful for inspiration, but indeed the creativity is really limited. And also with the huge spreading use, since humans, we are quite lazy, we could also just don't take the effort anymore to think of what we want and just leave this AI create for us. My vision is the opposite. It is really to try to develop smart tools to make us humans more creative. And this is what I have been doing in research for a very long time. I think it's better for us, and I think it's also better for the planet, because you will see that when we mixed learning with also priors that we have, then it will be less costly in terms of energy consumption. So what is my motivation in research? The visual representation, they are mandatory for humanity. From the beginning, was it art, in science, in engineering, we cannot understand the world around us, we cannot create new things without representation. These are images of pictures from Leonardo da Vinci, and if he could have 3D model, he could have explained even better what he wanted to do, for instance, with this flying wheel here. So if he had 3D, you can be sure that he would have been using 3D to express what he wanted. Indeed, if we just drawing are limited. Drawing are just two-dimensional depiction. And what we need to express something is to have 3D, 2D depiction, but with three-dimensional that we can turn around, and also time. Editing drawings is difficult. Also, when you have a pre-created animated content, you cannot interact with it. So what I try to do in my research is really to invent a new media that enables to go from the mental vision that somebody has of what they want to invent. Was this person an artist or an engineer or a scientist? We have a mental vision of our object of study. And we need a new media to be able to show this vision to our partners, to the people we are working with, to students, to the public, maybe to explain something. So my research is as a fence between 3D computer graphics, HCI, which is human-computer interaction, and artificial intelligence. To do that, I have a specific methodology, which was funded by the European Research Council. I had an advanced grant for 5 years called Expressive, and I will give you some of the basis of what I learned during these 5 years with this huge funding. So the methodology is based on 3 parts. We want the user to be able to express their thoughts, to express their vision through gestures. And these gestures are inspired from the way we interact in the real world. We want to be able to give the user the possibility to sketch what they think, to sketch, to sculpt, to transfer their knowledge. And the gestures are really important for that. Then we want that in front of this gesture, we have reactive, interactive models embedding enough knowledge to be able to react in the expected way to this gesture. Imagine, for instance, so you are here, a small audience. If I wanted my audience to be larger, which gesture would I do? I have modeled all of you in 3D, imagine. I would like to stretch you, to stretch the room like this. But maybe I don't want, maybe I want these round tables to become elliptoidal, but I don't want each of you to become larger. Maybe I want the people to duplicate. So in general, when I do a design gesture, I would like some of the part to enlarge, okay, to elongate, other parts to duplicate. And this is an example of the knowledge we want to put into the models so that they follow the user intent. And of course, we will need also to learn from example. Imagine I want to cover this virtual world to a distribution of this object. We will need to have some statistical learning from example, but we can make also this learning very light, and I will give you also examples about how we can transfer garments from a character to another with this methodology. Let me start by embedding knowledge in the models. So when I started willing to have the user in the loop for sculpting, our first research was using physically based model to try to have virtual clay that react in real time to the user gesture that you can sculpt. But we are not all able to sculpt something meaningful with clay, even with a real piece of clay. And designing these interfaces is very nice for research, but maybe not very so useful to create something. Now imagine that I have this little castle here, and I want to sculpt my little castle into a full medieval city. Could I have a clay which is a castle and remains a castle while sculpting? If I look at the rules here, you see that if I divide the castle into several parts, I have some rules. For instance, if I remove a part of a wall, a castle remains a castle. If I exchange the towers with the flag with the tower without flag, it remains a castle. If I add a piece of wall, it remains a castle. So let us now have a castle that can be sculpted by clay just by gesture. So it's a mix of elastically and deformable models which applies on the rules on the fly. So you see the knowledge is really interactively applied. If I cut a piece of this clay, then some towers will be brought, and all the rules are applied at the right place. So in the few gestures, the person can sculpt something which is meaningful for them. Let me give another example of putting knowledge in the models. If I want, sketching is first much easier than sculpting for most people. Putting sketch in 3D was our old research, how we use implicit surfaces, that each time you sketch, you have a 3D model which is created. This is instant, and even children can use it. But then if we add more knowledge in this model, so this is an example of knowledge with developable surfaces. All the products you see here are made of pieces of surfaces that were created with planar surfaces and then folded to create a 3D model. So if we add this knowledge of developable surfaces, first of all, we don't need to sculpt again the garment on the little girl if we have it on the mother model. We can just copy-paste, but this is smart copy-paste. And the smart copy-paste will also take into account the proportion of the human body, the fact that the little girl has no breasts, for instance, and you see that the patterns are not just scaled down to the size of the little girl, they are really changed based on the morphology. If we add this knowledge of developable model, we can do that. We can also, just from a couple of sketch, have, from the sketch of the boots, we create automatically the 3D model of the boot with this knowledge, and then we can have as well the 2D patterns to sew them. And this is, and now the last extension of this work is we just overdraw on a photograph, and we have this, we create the 3D model and we create the pattern. So just by adding this knowledge, we don't need to learn on a huge number of photos, even if some people try to do the same with deep learning. This is at least much more energy efficient because here we have the model, we have the knowledge. So it's just ridiculous to use something that costs a lot of energy for me. Another example of this is a work in science. Here we worked with a geomorphologist called Jean Braun, and we wanted not only here we sculpt clay, but what we wanted was to sculpt mountain ranges. And here you just need to put your fingers on a virtual table, and we have a model that is applied in real time. So following the motion of your fingers, it will collide two tectonic plates together, based on the knowledge that the plates will deform at constant volume, it will fold, and it will erode at the same time. So to create the virtual world with these mountain ranges, but also to work for geologists to explain their models to colleagues and students, you can really model the creation of these mountain ranges in real time. So it really brings you to a metaverse that makes sense here. And then you can explore this, and compared to the virtual terrain you see in video games, here we have a three-dimensional terrain. So you see the layers of eroded ground. You see this because we have a volumetric model of Earth's crust, so when it erodes, you see the different layers of different rocks, for instance. So this is an example of what we can do with this idea of sculpting and adding knowledge in the model. But in some cases, you need some learning. Artificial intelligence is not only expressing reasoning and knowledge, it's also learning from example. In my case, what I like is also enabling learning from light example, green learning, light learning from small example. Here the user has positioned by hand just a few trees, just a few blades of grass, just a few pieces of rocks, with the rules that he wants the rocks to be on the slope, and he wants the trees to be in flat areas, and the grass near the tree. We will have some statistical learning on that. We can learn from user-created example. We can also learn from photos. Here we learn herds of animals from photos. And here we learn from simulation results. Here we want to populate huge environment with ecosystems. So we will grow our little ecosystem on little pieces, and then we will learn the distribution. The common point of all this work is that we learn with the so-called point basis function. And so we learn the distributions and the correlation between all these in the example, either from photos created by hand or computed. And this will enable us to create huge virtual worlds with this. So let me give a last example. Last example is of creating a metaverse that makes sense, is applying this work on creation of ecosystem with prehistorians who want paleontologists, who want to recover how was France, Valley of Totavel, in the south of France near Perpignan, where they discovered, in fact, the first Homo erectus, the ancestor of the Neanderthal human. And so they have their mental model. This is really an example where the scientists of other discipline, they have a mental model of how used to be Totavel Valley 400,000 years ago, so a very long time ago. They have also a digital elevation model of this valley. They have information because of the cave they found, because of the flora, of the fauna. But what they want is to be immersed into their models. So this is really a metaverse that we created for them that makes sense, because this is their only way to travel through time and be there with their own thoughts, with their own hypotheses and their models, so that they can play with their models and change them. So you see the user is always in the loop. From them, we have the hypothesis on the natural resources, on the climate. So we have a series of maps, and from this map, we set up something that will compute exactly where each plant species will grow in the Totavel Valley. And then from the plant species, we have the herds of herbivores. From the list of herbivores that they give us, we figure out where they will choose to graze into the Totavel Valley. And from this list of herbivores, we have also the carnivores that are added on top. So finally, what we provide them is something that enables the tools and enables them to explore their own hypothesis, to travel into their valley, to go to meet the animals. They have models, and really they have a better sense. Instead of seeing just an Excel sheet, as says a person before me, with a series of numbers, they can really see the result of their model and be immersed with them. And you see, for instance, these grazing animals. And it's very interesting for me to be able to apply all what I did in the last 20 years with these paleontologists, because it mixes the need of having realistic terrains, realistic fauna and flora. Here you see some carnivores here. And the fact also to have people expressing their hypotheses. So in conclusion, what I want is to build on artificial intelligence to enhance human creativity. this is another example of our prior work where we build new 3D models by learning and learning how to combine existing models. But is it what we want? Do we want to press a button and have lots of 3D stuff which is created? Maybe it can be useful for inspiration. But what we want is really to keep the user in the loop and have smart models that help us express our own mental vision. So for this, we need models to enable to interpret design intention, to automatically duplicate details, because we will save time if the model duplicates the details automatically, maintains constraint automatically, and we want to be able to add knowledge and to add also light example on the fly, really on the fly. And I think this applies to art, to science, and to engineering. It will be better for us and better for the planet. Thanks a lot for your attention, and I want to ask that we are looking for industrial partners and sponsors here at Ecole Polytechnique for our research. In particular, we want to enhance research in the mix of art, science, and application to society. And also I created a master, Artificial Intelligence and Advanced Visual Computing, which is also looking for industrial partners. Thanks for your attention.
Well, Marie-Paule, I think you're definitely in the right place if you're looking for, like new guests and supports, of course, here and sponsors. We do have really quick minute to actually answer questions with Professor Cani, if you do have a question, because this was quite a fascinating interpretation of AI and, like trying to support human creativity through all these artificial intelligence tools is definitely mind-blowing. So do we have one question for Professor Cani? We don't? We do. Thank you so much. Wait a quick second and we'll provide you with the mic.
Thank you very much. So you show all the progress you've made in the past 10 years. You show that basically today large model can do it pretty inefficiently. But like when we mix the two, like what is the next thing that you're going to chase? Like, if you look in like 5 or 10 years, what is the thing that you're going to be super excited with what you've developed?
So I think that really my next research is really to give some meaning to the metaverse. Is really to be able people to share, to build together, to think about the future of their world. I think that 3D graphics is the only way to visit worlds that we cannot visit in real. Of course, we can always scan what is around us and reconstruct the numerical digital twin of what we have, but this is not really useful. What would be really useful is this metaverse can enable us to travel in the past, this was an example, but also travel into the future, and maybe work together on how to build the society of the future, because the climate is changing, society is changing very fast. Maybe people could go to this metaverse to build together the society they want to have in the future. And I think giving sense to this metaverse would be really useful.
Dreaming of a new society into the metaverse. Thank you so much, Professor Cani. And I'm going to keep this idea of getting a metaverse that actually makes sense for the next segment. Thank you so much. And Professor Cani definitely deserves some applause.